Good afternoon, guys. I hope everyone is doing great. So from this week onwards, we'll be having our classes online, right? So just before we start, I want everyone to just click on your participants and find your name and rename it as this. Just check your chat box, right? You should be having something like this as your name. Yep. So check your chat box. Your name should be in that particular structure, right? So please rename your username as that particular in that particular form, right? So, and the other thing is that while we'll be conducting classes online, so I guess most of you won't be taking down notes. So what I want you guys to do is actually, while I'll be explaining, I want you guys to actually take screenshots of this, right? You guys will be submitting this online, isn't it? You'll need to submit your tutorials through your Dropbox, right? So please do take screenshots of this, right? Because you'll be using this later on to build your solutions for your Dropbox, right? So let's start off with this this week's tutorial. We have two questions for this. Question number one, we need to answer the following based on PIC 18F6 hardware features, right? So we need to explain about real-time clock and the current sync and source capability. So the first one. So for the first one, for real-time clock, what is real-time clock? The name itself defines it, right? So when we are talking about real-time clock, basically we are dealing with real-time date and time, right? So a microcontroller has this feature inbuilt at times, but it is not necessary that the microcontroller will be having this as a built-in feature, right? So it says that real-time clock enables a microcontroller to have a absolute date and time information continuously. Built-in real-time clocks, right? Built-in clocks are not common in most microcontrollers.
Yeah, it's coming from that end. It's also the two lines. What side? BSP. Yeah, it's coming both sides. Yes.
Guys, I need you guys to mute your microphones, right? I think we are having interference in this class as well. So unless or until if you have to ask something, then only please unmute your mic. Otherwise, please mute your mic. All right. Okay. So let's continue, right? Let's continue. So we were at real-time clock, right? So yeah. So real-time clock is basically a feature that a microcontroller has to determine the absolute date and time information, right? It is not a built-in feature. It does not necessarily have to be a built-in feature for a microcontroller. It can be implemented using a dedicated real-time clock chip or program. So some microcontrollers have this feature, some microcontrollers do not have this feature, right? So it depends on the microcontroller. Otherwise, if the functioning of real-time clock is same, right? The term itself defines it. Basically, we are dealing with the real-time date information that is transmitted to the user, right? Part B, current sync and current source capability, right? So current sync is basically the ability of a microcontroller to withstand the, what do you say, the drawback current or the kickback current that is that is supplied from the instrument that it is operating, right? Or the ability of the microcontroller to withstand a certain amount of current, right? So when we let's say when we are operating a motor, so when the motor is operating, what happens is that it will generate some form of current, right? So it will generate some form of current, and that particular current will flow back to the microcontroller, right? So there are other instances when we are using other devices or other we are controlling other peripherals. So there is some sort of current growing, given back to the microcontroller. So basically that is the sink current, right? So current sink is basically the ability of the microcontroller to withstand a certain amount of current, while current source capability is the source the source term itself defines it. Basically what we are doing is we are sourcing current, right? We are giving out current. So it is basically, when we say current source capability, basically we are dealing with the ability of the microcontroller to source current, right? So it says this is important if the microcontroller is to be connected to an external device which may draw large current for its operation. Big microcontrollers can source and sink 25 milliamps of current from each output pin, right? This current is usually sufficient to drive LEDs, small lamps, and etc. The current capability can be increased by connecting external transistor switching circuits or relays to the output pins, right? So, so it says that microcontrollers have a capability of around 25 milliamps. So it is able to withstand 25 milliamps. At the same time, it is able to source 25 milliamps. So basically, if you are using if you're connecting some device that draws more than 25 milliamps, you need to connect it using a relay or some sort of switching circuit, right? Some sort of amplification circuit in this particular case, right? You might have learned it in your EE313 that there is some transistor circuits for current amplifications and so forth, right? So you have to be sure when you are connecting a device, you should be alert how much current it is going to draw and what kind of interfacing you need to use, right? For guys who are using motors in their particular projects, so those guys have to be really sure they use the driver circuit. If that is not connected, then what happens is that if you directly connect the motor to the microcontroller, there are huge chances that you are going to be damaging your microcontroller, right? So it is really important that you use a interfacing circuit, right? So that's for current sink and source capability, right? So let's move on to question number 2, right? I hope everyone has taken the screenshot of this particular question, right? Question number 1, because most of us won't be able to write it that fast, right? And after all, you need to submit this tutorial in the Dropbox, right? There's a Dropbox on your Moodle shell. So please do take a screenshot, and then later on you can write it down during your own time, right? Okay. Question number 2, right? Those who just recently joined in, please do take the screenshot of this quickly so that we can move on to question number 2, right? Okay, so let's move on to question number 2, right? Okay, question number 2. Question number 2 is to develop a mechatronics system to control the desired temperature in a gain storage area. The complete controlled system using the PIC microcontroller, driver circuit, and the sensor is given in figure B. Write a programming logic so that the temperature inside the closed grain storage area is maintained exactly equal to 35 degrees Celsius. Heater is used to increase the temperature. A blower is used to cool down the temperature quickly. A current temperature is used to sense the temperature, right, in this particular case, which is interfaced with one of the analog channels of the microcontroller, right? So basically what this question is asking you to do is to design a program, right, in order to keep the temperature of a storage area constant, right, that is at 35 degrees. So if the temperature increases, what you'll need to do is to cool it down, right, isn't it? If temperature increases, you need to cool it down, right? So when the temperature decreases, right, basically when temperature decreases, it means that things are being cooled down. So you need to heat it up again. So you turn on the blower in this particular case. I mean, you turn on the heater in this particular case, right? Otherwise, if it's at constant 35, you need to keep it constant, right? So it also says that you'll need to interface the temperature sensor to, right over here, it gives the sensor name and it is connected to an analog channel. So basically what happens is that you are using an analog sensor in this particular case, right? Isn't it? So if we are using an analog sensor, we'll need to utilize the ADC of the microcontroller, isn't it? Because all programming or other processing ability of the microcontroller is usually done in digital form, isn't it? So we'll need to convert this analog signal into digital signal, isn't it? So that is why we'll be attaching this particular analog sensor to the digital, to the ADC form. So okay, let's just see the circuit over here, right? Microcontroller circuit. This is the storage area, and that storage area is connected to a 5-volt power supply, right? That is then connected to the microcontroller, right? The microcontroller needs power to operate, isn't it? So that is connected to a microcontroller, and then we are using a heater and a blower. Okay? Remember, the heater and the blower will be using more than 25 milliamps, right? They'll be drawing at least somewhere close to 1 amps. So that is why we'll need an interfacing circuit in this particular case. That is the driver circuit, right? This is basically the protection circuit, we can say, right? And the amplification circuit as well. So always make sure, like usually in your exams, you'll be given the question and then you'll be asked to make the interfacing circuit. So whenever you are interfacing a motor or some sort of peripheral that requires more than 25 milliamps, you'll always need some sort of interfacing circuit, the relay circuit or the driver circuit in that particular case, right? So always remember that, right? For the solution part, right? For the solution part, okay. So for the solution, we need to assume that it is the temperature sensor is connected to a ADC, definitely, right? So in this particular case, we'll assume that it is connected to port A1, right? It is connected to port A1. Let's assume it's connected to port A1 pin. And the heater and the blower are connected to the port B0 and port B respectively, right? Let's assume that. Then what we need to do, the program will go in this particular form, right? I mean, just to give you an overflow, this is how the program should be. We have a temperature sensor, isn't it? Then what we'll need to do is to actually measure the temperature, right? Based on the temperature measurement output, we'll need to update it constantly, isn't it? So just in your mind, you'll be, you can just figure it out just knowing this, that it has to be in a loop, isn't it? Continuous measurement of the temperature has to take place, and based on that temperature, you will need to turn on the heater and the blower in order to maintain a constant temperature, right? So the first thing is that we connect the sensor to the board, right? So when we connect the sensor to the microcontroller, we'll need to initialize the analog pins, isn't it? Since we are going to be using the ADC. So the first part is to initialize all the ADC parameters, right? So that is what is being done here. That is, we are initializing the ADC, right? The highlighted part is where we are initializing the ADC, right? We need to set up the ADC clock internal, right? And then we need to set up the ADC ports, right? That is defining all the ADC ports as analog. And then we have to define the channel that we are using. In this particular case, we are using port A1. So port A1 is attached to channel 1, right? And then once we have initialized this, always remember when we are initializing or when we are switching between a peripheral, we do give some form of delay to stabilize the system, right? So that is what has been done here. We give some form of delay in order for the analog, the ADCs to be initialized, right? So once we have that, then like I said, we need to, in order to maintain the temperature, we need to go in a infinite loop, or we need to operate this this particular operation in a particular loop. So for this particular case, the best operation would be a while loop, right? Because for a for loop, for a do while loop, I mean, you can use a do while loop, But for a for loop, an if else statement, it is not applicable in this particular case because those are definite statements, right? After a certain amount of operation, it will stop. For this particular case, we need to keep it operational, right? So we keep the rest of the program part in the while loop, right? So the first thing is that if we define the while loop, right? And then what we do is we start to read the ADC signal, right? We start to read the ADC signal from the sensor. So we are doing that in the first line. And then, like I said, once we are switching the operation, we need to stabilize it, right? So we give some sort of delay in order to stabilize the ADC, right? In this particular case, we have taken the reading from this from the analog sensor. Now we are converting it to the digital form, right? So we need to stabilize it, right? So we give some form of delay. So second line is what we are doing over here, right? And once we have the temperature, it is basically the number of pulses, isn't it? You might have learned this in your classes, that ADC signals that you'll be receiving will be in form of square pulses, isn't it? Some form of pulse, right? Okay. So once we have retrieved that pulse or that pulse count, we need to calibrate it, right? We need to calibrate it or convert it into a particular temperature reading that we can interpret, right? Let's say from a sensor you get some form of wave count is 300, but what does that 300 mean? So we need to convert it into a sensible form. Oh, that is what we call calibration, right? So we need to calibrate that sensor, right? You guys will be doing this in your projects as well. Those of you who are using the temperature sensor, those who are using the what else? The motors. Those people who are using the motors, and then those people who are also using the ultrasonic sensor. All of you guys, I mean, all of you are going to be using sensors definitely, right? So you'll need to calibrate it. So in this particular case, you take a reading from the digital sensor, we need to calibrate it. So this is what is being done here, so that the values are converted to a sensible form. So in this particular case, we are trying to keep the temperature at 35 degrees Celsius. So we need to convert the temperature into degrees Celsius, right? So once we have the temperature, right? Like I said, we have two things, right? We have a heater and a blower to maintain the sensor. So if the temperature, we use a if else statement. If the temperature is equal to 35, do we need to turn off the heater and the blower? No, right? We don't need to turn on the heater and blower because the operation is as intended, right? We are already maintaining the temperature as 35 degrees, right? So that is what is done over here. Then in the else if statement, if the temperature is less than 35 degrees, that means the temperature is going down or it is cooling down, right? So we need to increase the temperature, right? So that is what is being done. So we need to increase the temperature. In order to increase the temperature, we turn on the heater, right? So if the temperature is less than 35, we turn on the heater, we turn off the blower, right? We need one of it. We can't turn on both, because if we turn on both, what will happen? Nothing will happen, right? Isn't it? Because the heater will be contributing 1 degree change, and then the blower will also be contributing 1 degree of change, right? But it is always safe because we are not sure how much temperature change contribution both the heater and the blower will be contributing. So it is always best to turn both off and only switch one, whichever is needed. So in this particular case, if it's less than 35 degrees, we'll need the blower. So we turn on the blower. I mean, we turn on the heater, sorry, right? We turn on the heater and we turn off the blower. If the temperature is increased to, if the temperature reading is greater than 35, we need to cool down the system. So we turn on the blower, right? We turn on the blower. This is what it means. And we turn off the heater, right? So that is basically the operation, and then the program finishes itself. So this program, it's inside a while loop, so it will be continuous, right? Okay. So now for your tutorial, I mean, solution that you will be submitting will be slightly different from this, right? Slightly different from this. You'll need to actually, this is done in a simple programming form. What you'll need to do is to write the same program using an external interrupt, right? when you submit this program, it should be in form of external interrupt, right? I'll give you time to take screenshot of it after this, right? But this is what you'll need to do, right? I'll be changing my window. Okay, you can see my screen? Guys, you can see my screen? You can write it in the chat box, right? You can see my screen, right? Okay, this is from your lecture slide, right? Okay, you can see my screen. This is what you need to do. This is from your lecture slide, right? You just need to go to lecture slide 125. The what do you say? The lecture notes has this particular program using the external interrupt using an ADC as well, right? So this is the program that is given here for using an how do we use the external interrupt, right? In order to incorporate a external sensor. So what you'll need to do, this is the main program that is given. You'll be doing the same thing in your program as well, right? You'll write the same thing up till here, right? As it is, this is already given in your main program. The additional part will be from here, this part. You'll need to enable the interrupt and write it as while one, right? So basically this part is the new additional part. The highlighted part is the new additional part to your program, right? You'll add this just after the initialization of the ADC, right? You'll add this and then you'll close the main program. You'll close it and you'll move on to the ADC part. Now, where we wrote our, this part, this while loop, the whole of this while loop, right? This particular part now needs to be, now we need to place it inside this particular loop, right? This is the interrupt function. This is where we'll place this entire while loop into this, right? So that's how you use the Ashnil. Actually, you can't see what I have written. Nothing is highlighted. I'm really sorry. You guys aren't able to see this, but don't worry. After this, screen is still on what? Okay, just hold on. Just hold on. Hold on. Okay, sorry. Now I've changed it to where the lecture slide is, right? Sorry about that. Right. Now you can see my, can you see the lecture slide again? I've switched back. Yes, right. Set. Now you can see the lecture slide, right? Okay, this is what you need to do, right? I'm going to explain again, right? Just go to lecture slide 125, right? This is the main part. Whatever you have written in your Word program, I mean, the main program that I'm going to give through the solution that I'm going to be giving, right? You can take the screenshot of this afterwards, right? What you'll need to do, the main program as it is, up till main program, everything will be as it is. Up till the ADC initialization, everything will be as it is, right? This part is as it is, right? The only thing you need to add is this part, right? Enable interrupt from the part where you enable the interrupt up till the while one part, right? So basically your main program will be something like this, as it is, as written over here, right? On this particular lecture slide. All right. Everyone understood? Yes or no? Just one of you can just type it out, right? What needs to be done? The main part will be as it is, right? All right, all good. Okay, now here's the interesting part. The program that is inside the while loop, the simple program that I just showed you in my Word document, right? In the while loop, you'll need to place it inside this, right? Inside this particular loop, where you write hashtag int ad void adc underscore done, right? Inside this function, you'll place, in place of these codes, you'll place the entire while loop code that you'll be getting through this Wix tutorial solution, right? You just need to place all the solutions over here. Is that fine? The while loop, the entire while loop, the entire code inside the while loop, you just need to copy it and place it inside this particular loop. in place of this highlighted text, right? The purple text. All right. And in that particular way, you'll be able to write the external interrupt code, right? So that's how you basically write a code using external interrupt, right? Okay. Now, let me switch back to the Word. I think most of you haven't got the code, right? This one. So share. So let's go back. So I'll give you some time. Please take the screenshot of this code, right? And then I'll scroll down. You'll take the rest of the code down, right? Take the screenshot of this, please. Once you have done, please write. Please do write in the chat box that you have completed taking the screenshot of it, right? Just write done. Okay. Okay, right. So I'll scroll down now. All right. Okay. So now you're here. So now you can take the rest of the code down as well. Take this screenshot, and that will be the total program for question number 2. Right. Take the screenshot of this as well. You just need to press the Windows key with the print screen key together, right? You'll be able to take the screenshot of it. Just for those who don't know how to take the screenshot of the program, right? Okay. Like I said earlier on, you just need to copy all this code, right? So we need to take this, we just need to take this code, right? The entire while loop code from here to here. We need to copy it and just place it inside that particular interrupt, the interrupt function that I showed you earlier. You just need to copy this and place it inside that interrupt loop, right? And that will be your interrupt. I mean, that will be the code for this particular part using the interrupt, right? The external interrupt. All right. So all of you have got the solution, right? All of you have got the solution. Explain 0.483. Okay. Okay, wait, let me explain this part, right? Is there someone else in the waiting room? Okay. This particular part, this 0.483 is the calibration constant, right? It is something that has been like, when you calibrate something, it is out of phase or something like that. You basically calibrate it. So this is what the constant means. It is just a calibration constant. While you'll be when you'll be calibrating your sensors, the constant will be different. It varies from particular sensor to sensor. For this particular case, it has been written as 0.4883. So basically it is scaling down the whatever reading you are getting, it is basically scaling it down, right? In your case, it can be also scaling it up or scaling it down. So don't focus that much on this particular calibration, right? Most of the time, it depends on whatever reading you have. You have to take the reading and then you plot it, right? You plot it on a graph and then you see, are you getting the expected result from that particular reading? So based on that reading, you calibrate it, right? You either need to take the reading and scale it up or down, or you need to shift it, isn't it? So you just need to scale it up or down or add some additional values in order to shift the reading, right? Basically what you are doing with a graph, right? Basically when you shift a graph up and down, so that is what is being done over here in this particular case. So calibration part, you'll be learning this in your projects as well. So for this particular case, this particular constant is just a calibration constant, right? So has everyone taken the screenshot of the solutions? Has everyone managed to take the screenshots of all the solutions? Yes. Is there anyone who is left? So if you have been left out, I can give the, what do you say? I can go back and let you take screenshot of these solutions again. Copy. Is everyone okay? Right. Actually, you don't need to type the whole solution down. You can do it on a paper as well. Take a screenshot of it and upload it. I mean, like, no, just take the image and paste it on the Word document, and then you can upload it, right? No need. Either you can type it, or you can just take a screenshot of that particular whatever you have written on your book and just upload it. I'm sorry, this session is at the moment recorded, though this session is being recorded. However, I'm not giving any sort of guarantee that this will be uploaded, as there's other tutorial sessions that are also going to be running, right? There will be other tutorial sessions that will also be running in parallel to this. So if we upload the recorded version, what happens is that most of the students do not attend the tutorial sessions. So I'm not giving any sort of guarantee that this recorded tutorial will be placed on your Moodle shop. However, if you need any sort of help, you can do contact me, right? Okay. Okay. Is there anyone who is left to take down the solution? No, right? Okay, all good. Then what I'll do, please do not leave the session. Let me just take the screenshot of all the participants so that I can update the attendance on Moodle as well, right? Based on this. We have 30 participants, so please do not leave yet. Okay, I'll just stop sharing the screen. Okay, I need to take the screenshot of this. Oh, those of you who haven't renamed your username, please click on participants, click on the username, write your ID inside the bracket or outside the bracket, write your name. Please rename yourself. Jonathan, Nusrat, Ramneet, please rename your usernames. Same goes for Samu, Shahil, Shaw, and Edwin. Please rename your username as your ID so that it will be easier for me to update it on your Moodle shell. Right? Just please rename it. Still waiting for Edwin and Nusrat, as well as Ashmit, Michael, and Luke as well. All right, so Nusrat.
Schmidt.
All right, so I've got your attendance now, right? So you guys can leave if you want. If you have any questions, you can ask me right now. Do you have any other questions? So late for submission of lab 4, whom should we refer? Please just if you have missed out on the submission of lab 4, lab 3, or lab 2, if you have missed out on the submission, please make sure this. You just need to submit that lab to Dr. Mehta and copy me into that particular lab. We'll mark and update it. There will be no penalties imposed on you, right? So please make sure you submit all the labs so that you are not lagging behind or your coursework is not reduced, right? Just in case if you have missed out on any of the labs. And the other thing, I have seen some of the students who have submitted incomplete labs. You can resubmit those labs, right? You can resubmit it and give in. Wait, let me stop recording this part, right? Yes. Okay. Right. If you have any other queries, what you can do is email me or Dr. Mehta regarding this, and we'll definitely answer your queries. You can either reach me out through my to my mobile. I mean, if you have my contact details, or through Facebook, or through emails, right? Whatever you find it convenient. But usually use the emails as it is more convenient, right? My email is, please do check the email address. I mean, the Dropbox, my email is given there. It is prasad_rr@usb.ac.fj, right? At usb.ac.fj. If you have trouble finding out my name, if you have trouble, identifying our email address, you can just always look up on your Moodle Moodle shell, right? Under participants, you can just search our names and our username is there. You can take that username and attach at usb.ac.fj. All right. So that's all for this particular week's tutorial, right? I'll see you next week, right? At the same time. Also, if there's some other students from the other sessions, they can also join into this particular lab session, right? Please ask them if they would like to join this particular session. They're always welcome. It's not limited as if you have signed up for this session, then you have to attend this particular session. We have 2 sessions. You can attend either of it, right? All right. Set. So I'm ending this meeting over here, right? Thank you for attending.